We are going to continue the unit 2 of explainable AI because this unit is theoretical AI concept with real world AI building system. Okay, so please listen carefully. So far we studied explainable AI concept, interactive learning, human involvement AI and beta models. Okay, so now in this sessions we are going to moving how an AI is actually built, tested, improved, selected and finally explained. What is that? How an AI model is actually built, tested, improved, selected and finally explained. Okay, so students, remember one thing: building an AI model is not just training a model and stopping. It involves the multiple important stages. Okay, and each stages play in a role. For example, accuracy, reliability, fairness, explainability. So today we will cover hybrid models, model validation, model evaluation, hyperparameter tuning, model selection and visualizations. All this together make AI trustworthy and usable. Okay, now let us first understand the big picture. Okay, so building an AI model involve the following stages. So first step, model design, which means designing how the model is built, right? Designing how the model is built. Second one is validation and evaluation. So it's checking the performance, right? Checking the performance and fairness. Third one is hyperparameter tuning. So it improving the learning behavior. Okay, it improving the learning behavior. Then fourth one is model selection. So model selection means choosing the best model, choosing the best model, which means choosing the best performer. Fifth one is visualization. So it's explaining the and understanding the result. Fine. So many students think if accuracy is high, is the model is good, but that is the wrong. Okay, a good model should be accurate, generalizable, explainable, fair, efficient. What is that? Accurate, generalizable, explainable, fair, efficient. So now let us start with the first major concept, hybrid models. Okay, what are the hybrids model? Now focus here. A hybrid model means combining two or more modeling approaches. Okay, combining two or more modeling approaches to build a better AI system. So why do we need this? Because one model alone may not be sufficient. So each model has a strength and weakness. Okay. So the hybrid model is aimed to, okay, use the strength of different models. Okay. So reduce the weakness of individual models. Okay. In a simple word, hybrid equal to teamwork between models. Hybrid equal to teamwork between the models, right? So what are the types of hybridizations? So these are the different ways to combine the model. The first one is statistical and machine learning models. Okay, for example, ARIMA, LSTM. Okay, ARIMA is a statistical model. LSTM is a deep learning model. So ARIMA good at trends. It a linear patterns. So LSTM is good at complex, so non-linear pattern. It's also the time series dependency, right? So when we combine ARIMA plus LSTM, so we get trend prediction and then pattern learning. Fine. So this is a very useful in weather forecasting. This is a very useful in weather forecasting, stock prediction and energy demand. Then second one is symbolic plus neural models. Okay, which means neurosymbolic AI. So symbolic AI rules logic and human readable. Neural networks, data driven, high accuracy and black box. Okay, so when we combine the both, neural network predict, symbolic system explain. So the student, the hybrid approach improve the interpretability, right? The third one is rule based plus deep learning. So rule based system show transparent and easy to understand. The deep learning is a powerful, is a accurate, not explainable, right? So the hybrid approach, the deep model does prediction. The rule system explain the decision. Fine. So this is a very common in explainable AI system. Okay. So now the students, why the hybrid model are preferred? So it first one is it improve the accuracy because the multiple models correct each other. Second one is the robustness. So if one model fails, another support it. The third one is explainability plus power. So one part explain, another part predict. Okay. The fourth one is handle the different data types, which means the structured data like tables and then unstructured data like images or text, right? So in the real world example, the credit scoring system. So the credit scoring system decision tree, it generates the rules, which means it's explainable. The neural network detect the complex pattern. Okay, it combine the result, the accurate credit approval. Okay, the transparent explanation to the customer. So students, hybrid models are very powerful in a real system. Have you understood? Okay, now let us see the challenges. Okay, first one is interrogation is complex, right? Different learning styles are hard to combine, which means harder to debug or tune. Okay, and then debugging is difficult. Then computational cost is very high. Okay, and then finally the explainability may still suffer if one part is a black box. Okay, so student, hybrid model must be designed very carefully. Have you got it? Move to the next slide. Okay, now we can move the model validation concept. Model validation, first to understand this clearly, a model performing well on the training data does not mean it a good model. Okay, so the model validation checks how will the model perform unseen data. Okay, how well the model performs unseen data. So it's a main purpose, ensure the generalization and then avoid memorization. Okay, ensure the generalization, then avoid memorization. So in a simple word, validation check whether the model has a really learned or just memorized. Okay, it's like a student teacher. Okay, so validation check whether the model has really learned or just memorized. Okay, have you got a concept? Okay, so common validation techniques. So the first one is train test split. The second one is holdout validation. The third one is cross validation, which means the k-fold, very important one. So we'll see one by one. Test, train, test. Okay, train, test, split. First, split the data into training, testing. Okay, for example, if the data 100% mean the 80% of the data is going to testing, training the part. The 20% of the data is going to testing the part. So split the data into training and testing. So simple but maybe biased. The second one, holdout validations. So holdout validation mean it's a similar to train test. Okay, but the fixed split. Okay, how many split? Na? For example, 70% or 30%. It may be fixed for all. Okay, then third one is cross validation. It's the most important one. The data split into k folds. Okay, so the model trained a k times. Okay, so already you studied in the machine learning or AI k-folds cross validations method. So the data split into the k-fold. The model trained k times. So the average performance calculated. So this is a very important. Okay, have you got it? Okay, in a k-fold cross validation, in a k-fold cross validation, data is divided into k equal, as already I told that. Okay, so train and k minus 1 parts. So test and 1 parts. For example, if a k value is 10, we can train the data k minus 1, 9 minus 1. Okay, which means 8 data are trained model. Finally, only one data are testing part. Okay, repeat the k times. Okay, finally the average score equal to final performance. So why do we use this? Reduce the bias, give a reliable performance estimate, right? Got it? So this is widely used in the model selection and tuning. Okay, now students, once validation done, we must evaluate the performance. Let us see the slide. Okay, evaluation metric depends on the type of a task. Okay, evaluation metric depends on the type of a task. Okay, the classification metrics is based on accuracy, precision, recall, F1 score, ROC curve and AUC curve. Okay, so accuracy, so overall the correctness, so not reliable for the imbalanced data. So precision mean how many predicted positives are correct. Okay, recall mean how many actual positives are identified. So F1 score balance between precision and recall. ROC curve and AUC curve, it shows the trade-off between true positive and false positive rate. Okay, true positive and false positive rates. Got it? So regression metrics, that are the three. Okay, MAE, MSE, R squared. MAE mean absolute error, MSE means squared error. Okay, so mean absolute error for average the absolute error. Okay, mean squared error the penalize the large errors. Okay, R squared score meaning it measure the goodness of it. Okay, so very important for this subject, the explainable AA metrics. Okay, uh, the first one is fidelity. So how well the explanation matches the model behavior. Okay, the second one is interpretability. So how easily humans understand the result. Okay, for example, the loan prediction model. So for accuracy 92%, F1 0.89. So students, evaluation is not only about accuracy. Okay, have you got it? So as already I told that model evaluation. Okay. Okay, students, now move to the hyperparameters. So the hyperparameters are settings chosen before training. Settings chosen before training. So they control how fast model learns and how complex the model is. They are not learned automatically. Okay. So for examples of hyperparameters are learning rate, number of layers, number of neurons, regularization strength, decision tree depth. Okay. So the wrong hyperparameters are poor model. The correct hyperparameters are strong model. Okay, have you got it? Okay, how do we, now let us see the how do we choose the best hyperparameters. Okay, which mean hyperparameter tuning methods. The first one is grid search. The grid search meaning try all the combinations. Okay, accurate but slow. Second one is random search. So tries the random combinations. Okay, then faster than the grid search. The third one is Bayesian optimization. So usually it uses the probability. So efficient and smart. The fourth one is automated ML, which means the auto ML. Okay. So AI tune itself. Okay. Minimal human effort. For example, XGBoost model, learning rate plus tree depth. Okay. Grid search plus graph validations. Have you got that? So now the students, after the training multiple models, we must select the best one. Okay. So model selection depends on the validation score, bias variance balance, explainability, fairness, computational efficiency. Okay. For example, logistic regression with random forest. So even if a random forest is accurate, we may choose the logistic regression. Okay, so interpretability is required. So students, best model not equal to most complex model. Okay, so visualization in explainable AI. We come to visualization finally. So which is very important. Visualization is help to interpret the model, debug the errors and communicate the result and build the trust. Okay. So visualization, it helps to interpret the model, debug the error, communicate result, build the trust. So common visualization techniques are confusion matrix, ROC curve, feature important, sharp plots, decision tree path, grad cam and attention map. Okay. So visualization make a model behavior visible. So now students understand everything uses one example. Okay, for the domain healthcare, the hybrid model CNN plus rule based system. The validation for five-fold cross validation. The evaluation for accuracy equal to 94%, recall 0.92. So the hyperparameters, learning rate 0.001, path sizes 32. So visualization, GradCam highlight infected lung area. Okay. So the doctor understand why AI predicted pneumonia. Okay. So it is explain everything with the rule. Okay. This is a explainable AI in a practice. Have you got it? Okay students, so let us summarize. A hybrid model improve the performance and explainability. Validation ensure the generalization. Evaluation measure the correctness and trust. Hyperparameters control learning. So model selection chooses the right model. Visualization explain the decision. So together these make a AI accurate, reliable and explainable. Okay, so please revise this unit is thoroughly. Okay, next slide we will discuss the another parts. Okay, real time case studies. Okay, so have you understood the student? Thank you.